Okay, you can all relax now. I know it's late. I know you are all tired. I saw some people just sleeping there on the presentations, using laptops. So I'll try to keep it simple. I try to keep it light because the topic is light. Because it is Scala from B to F, it means from the backend to the front end. So for those who know what Scala.js is, it's going to be, I hope, a good reminder. And for those who do not, I hope it's going to be a pleasant surprise. So that's that I'm supposed to be here. So a little about me. So I'm a full-stack developer. I love functional approach to coding. I'm a big fan of Speedway, if you know what it is. And I get easily interested by new stuff, like creating my own antennas and catching signals out of satellites. There is Poland right there. It's not easily visible. And that's my wife holding antenna against the window in the winter. That was a huge help. Yeah, what I do professionally, I work in Talk, software house in Warsaw, and I work with NewSnacker. So that's the tool to work on real-time data. We've implemented NewSnacker in 3 major telco companies, and we've also implemented in one big financial institute. What should be interesting for you, it's open source, and it's written in Scala. We use it for fraud detection, credit scoring, real-time marketing or recommendation, and much more. What is cool about it for me is that I can focus on developing new features, and domain experts, our clients, can focus on creating new diagrams with our tool. Well, OK, let me start with the presentation already. You all know that image. It was in so many memes. I'm sure you are familiar with that. That's how most of people see application, normal application. There is supposed to be beautiful front end, ugly backend. Nobody knows what is happening there, and the user happy to use it. But well, I'm not the UI designer, so that's not the case for me. For me, it's more like this. I have to create, from time to time, admin panels or some other UIs, but it's not always look nice, right? I do not spend too much time on positioning, colors, etc. But I do care about backend. I try to make it nice. We work with Scala, so we have the tools to make it solid, concrete backend, which looks nice and it's pleasant for the eye. And those are my friends at work who have to use my admin panels, and I have to use them, theirs admin panels as well. So that's how it looks like. And how we see a basic application right now. We have some backend with a Scala, Akka or CATS or Zio or any other tool you want there on the backend. And we also have a frontend. And on the frontend, we have JavaScript, but not. We do not want to write in the JavaScript. So we use TypeScript to have some type safety at all. But when we are starting to write in TypeScript, we are adding new libraries to make our code look more like a Scala does, right? We need a lot of tools to work with the new stack, which you are not used to, if you are a backend developer, of course. So when we create some data models on our backend, we have to copy them on the frontend as well. Very often, we have to change the validation, copy-paste validation, rewrite it in the new stack. And if something changes, we have to change it in the frontend as well, very often in the database also. So what we are ending up with is something like that. We are trying to make from the JavaScript something that looks like Scala. Well, as you can see from this image, it's not going to be any faster. It's not going to run any better. We are just trying to adjust the tool to our needs. So the basic question is, does Scala know how to front-end? Well, it does not. But there is something that shocked me when I was young and shocked me recently as well, but when I discovered this tool, is fusion. Fusion of Scala and JavaScript. And the result of that fusion is Scala.js. And what Scala.js is? Scala.js is a compiler which compiles Scala code to the JavaScript. Let's say that it is exactly like that, and do not put a lot of thought in the documentation, etc. right now, because you have all of that online. There is a very good Scala.js page with basic setup, examples like that. There is lots of content in there. There is also hands-on Scala.js by Lee Haoi, YouTube videos or cross-platform language design, which very good present you how Scala.js works from inside, how all this type translates to each other. It has 184 pages. It was written by Sebastian Durain and give him a PhD degree. And he's also the creator of Scala.js, so congratulations to him. Well, Scala.js is not a new concept. It's not the new tool that compiles something to the JavaScript, so we wouldn't have to write in JavaScript at all. There's lots of other tools. I've come with Kotlin and Scalar, and GV2 as well. And as you can see, lots of alternatives out there as a tool which compiles to the JavaScript. Well, so let me show you. It's very basic, but I think it proves the point how easy it is to start working with Scala.js. I can fit it all in one slide, and it's not going to be a pile of code. So we add SBT plugin. We add 2 lines to our SBT file, which is we are enabling plugin, and the second line is optional, but it helps you work at the beginning. And then we create a basic Scala word, hello world example, as we would in Scala. It's nothing specific here, it's just hello world, but customized for hello Scalar. We are using fastlink.js, and what we are ending up with is this file, which we've created, and it's JS file. It has our code compiled to the JavaScript, and well, we've included it into HTML page, like a normal script, and there we have our results. That's all you need to do to start working with Scala.js with Scala. But you may wonder, do you need to rewrite your whole application to Scala and compile it with Scala.js? Well, maybe there is a better way to start working with Scala.js. So, for example, let's say that you have some validations somewhere in your backend application, and you would like to take it out and import to your existing page written in JavaScript. Well, you can do that very easily. There is annotation for that, and lots of different annotation as well. But for that method, it's the valid one. And what it does, it says that after compilation, this method will be available in the top level of the JavaScript. So everything you are going to write in here is going to be compiled to the JavaScript, and you can use it by simply executing that method. So we are using fastlink.js once more. So let's forget it in the next slides. And there we have, that's our file, which was created. And a little bit further, we have console log and remove from sentence. And from, for instance, I'm removing from a word, to be honest. New snacker, we are removing k character. And, well, it works, and it produced us a new snacker. It sounds the same, but there is no k in it. So you get the point. Well, so it can. Let's put a label on that. There is also a different question. Let's say that you've already have some page written with Scala and Scala.js, and you're about to add something that you've created with JavaScript already, because you do not rewrite it to Scala the other way. So that's our library, right? So it's going to execute on some string to uppercase. We're going to have a big letters in there. And if we want to use that inside our Scala code and then later compile it to the JavaScript again, and we do not want to care about implementation of that, we do something like this, which is we say that this method is available in the global scope of the JavaScript. And we say how this method should look like, what its structure look like. And we say that we do not care about its implementation. We say that whatever happens there, we do not care about it, it should go from here. It should be somehow provided by the JavaScript. And then we have our main method, in which we use method defined right here without its body. So, well, let's see what happens. There we have our result. What a day. So, yeah, it works both ways. But there is also a case that you may not use plain JavaScript in your code, probably. And you are, for example, using React, which is very often used on in the production, and we've also used it in multiple places in our application as well. So we can use it in a different ways, but I've prepared something like that, which includes importing JS Bundler plugin. That's the plugin which will bundle all the dependencies we are going to provide in a single JS file, and those dependencies are right here. Those are NPM dependencies, just as we would import them in NPM. And we enable that plugin right here, and it should just work. We should get those dependencies downloaded. But we do have to have NPM on our machine. And well, now it's not looking good right now. As I thought at the beginning that it do not look beautifully, just because there is some builder in it and all of that, just to create a React element, React component. So what we are doing here, we are using a builder to create component which has props, and we are using that props later to render some element. And a little bit further, we are using created template to actually render that into our DOM to the some container with ID app. Well, you can do that much better. You can use templates provided on the GitHub page of the React Scala React.js and work with React components like you would with classes. And you have render methods, etc., and case classes to represent props and state. But that's the simplest example. Right here, we are using fastlink.js once more. There is a little sign here, tilde, which says that it's going to work as a fast reload. So that's good. We do not have to run this every single time we're going to change anything in our application. But there is also a Webpack which packs everything, let's say, all these dependencies with Scala Bundler to one single file we then include in our HTML page. Well, there it is. That's the simplest example. We have our shopping list, bread, milk, and eggs. And, well, it works. There is no shortcuts in here. OK, sorry, micro. And last thing with React, I hope, are facades, also for React. And you can use scalably type to do that. If library you are trying to use has TypeScript types somewhere, then we can use that library to provide facades for us. But if we do not, we can do that manually. It's not very pleasant at the beginning, but you can create your own custom way to do that, so you do not have to go with that pattern every single time. So what we are doing here is we are taking some fields from the documentation. I've took only 2 of them, which is theme and position, and we cast them to the props. So right now, let's say that's a connection between properties from that library and what we are going to provide in that method. And a little bit further, we are, well, I forgot to mention you that I'm doing that example on a React Toastify. I hope you know that library. If you are not familiar with that, it's just these little pop-ups, colorful, with a little line saying how long it's going to be displayed. Yeah, and we are saying that this component is going to be important from React Toastify, and its name is toast container. We need that container to display our pop-up, and we are creating that component here. So that's maybe not the best example to say that Scala.js is super awesome, because it's not something you would want to work with every single day, but you can make it a little bit nicer, like a lot of things in Scala and other technologies, right? You are creating your own shortcuts. Well, we also need some method to execute it, so to display the toast. That's a simple facade we saw earlier. The difference is that we are importing from some place, and we are saying that in the annotations right there. And as you can see, there is also a JS native. So what it does, it says that we do not care about implementation. So it's going to be taken from the JavaScript, TypeScript library. And well, that's the React part. As you can see, it's a little bit different now because I took only part of render method. And well, it looks a little bit similar to the HTML tags, but it does not look very nicely, to be honest, because of these greater equal signs, dots. But what it does is it creates container. Inside it, we create container we've just created here. So that's toast container we are going to use to display toasts. And there is a button which on click executes the toast method. Well, so let's see if it works, and it really does. I was surprised myself as well that it was that easy to provide props to work with React facades, to use React libraries. Well, it says this is awesome, but is it? Is that awesome? Is that awesome? Well, we may argue about that. So that's the one UI framework there is. There is also Calico. There is also Outwatch, Udash, and Laminar. And the last one is my favorite because it works using streams, and it works, to be honest, only on observables. So we can work this stream way kind of thing on our UI, right? We have streams to work there. I will go back to the Laminar a little bit later. But at the beginning, I told you that there is a backend and there is a frontend, and we have to copy data from one place to another, and we have to do that very often. Also with the database classes, which we define there, and we have to copy that logic to the backend, to the frontend. Well, let's see how we can fix that. And there is something called cross-project. I think that's the best part, and main reason to use Scala.js. Because with that, let's say that we have our Scalar 2023 project right there. We define that we want to cross-compile it to JS platform, to JVM platform, and, well, not cross-compile the whole code, but we are going to have different folders to that. So we have JS folder, which is going to be created manually, automatically, and settings to that module. The same with the JVM, and the same with the shared, which is just settings. Everything put in the settings is going to be also applied to JVM and JS setting. And, well, you can put dependencies and other settings like you would in the normal Scala project. So, well, we have something like that, so we can work with that a little bit further. Let's say that we have our shared project, right? And let's use Tapir and Laminar to work with that. Let's see how it's going to work. Let's define some case class, let's say user, with its name, surname, and age, and some validation, which is not important at that stage. And let's say that we also have Tapir endpoint defined somewhere. To be honest, I thought that somebody is going to explain that for me a little bit earlier in the presentation, because I didn't want to go too deep into that. But I think that it is enough to say that what we are doing here, we are creating simple endpoint, which takes query named name of type string and outputs JSON body, which is going to provide us a list of users. So we have Tapir endpoint defined right here and our user. So it's important to remember that we have it in a shared module. And let's go a little bit further. We have a JVM module right now, so it's supposed to be our backend. Normal backend, as we would write any backend nowadays. As you can see, I'm using endpoint, Tapir endpoint. I've defined it earlier. Well, I'm not from SoftwareMill, if you are wondering. Okay. Get users endpoint, and we are applying some logic to that endpoint. Let's say it's not important what it does right now. Let's say that it takes some data from the database and filter it by name. And a little bit further, we are creating out from this road, we've created based on Tapir endpoint, akka HTTP server. Well, okay. So I just pointed out that we are reusing all of that. And in the getUsers methods, we are reusing users case class. And now now we are going to the JS module. And in that module, there is a method. It's not important what it really does. What is important is that we are using HTTP client to call our backend. But we are not saying where should it to make that call specifically. Well, we are saying that it's hosted right here, but we are using endpoint, Tapir endpoint we defined earlier in the shared. So we have the same definition both on the backend and both on the front end. So if anything changes to that, it's going to be applied both on the front end and backend as well. So thanks to that, as you can see, we can type save execute call to our backend server and do not re-implement that logic in the JavaScript, TypeScript, or whatever other script you want to use. And well, that's part of Laminar code. As you can see, it's very similar to Scala tags, but it's a little bit nicer to read. It do not have all these greater equal signs, just a little bit nicer. And also do not have this weird annotation close to on click. We use this sign and dot on click and some callbacks. There is no callbacks here, not like it was there. But it works with signals and streams. And we have our button, which on click is going to filter users, so it's going to call the API and give us from the database users. We filter by the, let's say, condition that it has to contain certain letter in it. We are assigning that user set, and users table, I will just simply explain, is another Laminar component I've created, which what it really does, it takes list of users and creates table out of it. So this table is created by this method, so we do not have to specifically tell what arguments we have in our user case class. Is going to be taken from that, and also all the values. So well, that's the simple example how it looks like with Laminar. And well, why is it important, and why should we consider that? Well, firstly, if we change something in our data types, for example, we add color and it's set to blue, not to bother too much, it's going to propagate automatically, both on the front end, both on the server. So it's going to be provided from both sides with that field added. So no more cannot find, in this case, color of undefined, or no, maybe not that error exactly, but you get my point, right? If it's going to be more nested, you're going to meet that error eventually. And well, for example, if we are going with the new API, or we want to make some changes in our paths, or etc., and we add, for example, that we just moved our endpoint, well, nothing changes, see, because it's going to work. I try to make example if something is going to change, but no, it's not, and that's the beauty of it all. So what we started with, and how it is usually, maybe out of laziness, maybe just because it's convenient and people, maybe some of you like changing to other stack, is that we have the same approach, the same data models, the same helpers, validators, or something else written in JavaScript, and also in the Scala. So we often have to rewrite the same logic because we want to have the validation as soon as possible. So if the user is sending request, right, we want it to be validated quickly. We do not want to call backend to say us that something is wrong, some simple field is not correct, like, I don't know, name is too short, age is too low, whatever. And we also have to do that, the same thing on the database as well. We have to define our data model somewhere. Well, what we can achieve with Laminar, Scala.js, Tapir, cross-project, or Slick, I never mentioned that before, but you've got the point from the picture, is that we can use one place to define all what is important in our application. Of course, you can put some of these data models you do not want to share with the front end to the back end. That's fine, but you can, those who you want, which you want to share, you want to keep it in that place. And well, thanks to that, you are gaining a lot of time because you do not have to make well, refactors that consume very, very much amount of time. So what I would love to leave you with is the question I want you to give to yourself. And next time you are going to work with your application and you have front-end written in any front-end technology, you are going to, is it worth it to copy the same logic every single time? Is it worth it to go through the whole application when you change a single simple changes? And is it worth it to waste your precious time? And I would also like to point out one thing before anyone asks me that, just because I have time, that Scala.js, it's not always the great choice, not suited in every places. I want you to remember that I've showed you in the beginning that I'm using that mainly to using internal applications, not application that sees the end user or lots of them, right? Because it's very expensive to hire, well, Scala developers to write you a front end, and it's not going to be well maintained later by JavaScript developers, because this code is, well, you cannot work with the generated JavaScript code well. And I think that's it. Thank you.
Okay, and we have time for questions. So maybe, okay, there is a question.
Hi, I have 3 questions. So first question, does Scala.js also support JSX? Second question, yeah, why do all these developers insist on using parentheses for HTML tags? HTML tags are not functions, they have no logic, and using parentheses similar to like how functions just makes the code a little bit harder to read. And the third question, so Scala has the concept of like maybe, optional, or maybe monads, while JavaScript has null and undefined. And so how would you like map between the two and handle these tricky cases? Thanks.
Yeah, the first question, I'm not sure about it, but I can go through with it, but I can jump to the remaining questions. Why we are using that syntax, right? Yeah, because, well, that's the closest syntax that we are familiar with while working with Scala. How could we differently represent it? It's not very easy to answer that. It's not very easy to put Scala tags, which has different concept to the Scala code. And well, if you work with the front end and somebody else works with the front end, it's not going to be an easy change. I see it as a way that somebody who works with the Scala code to have easy way to go the other direction, if that's what you meant. Because why was it implemented that way? I don't know, but to be honest, I really enjoyed it. And how it maps, as you said, it is everything very well described in this cross-platform language design document. I'm not have it all memorized, but it shows you how every type is going to map to another. How this undefined, all that types are going to be handled when where compilator has to deal with them. I hope I answered a little of your question. If not, we can meet and talk a little bit more about it.
Thank you for your talk.
Hello.
I had a chance to write rich editor in Scala.js. And initially it was like very great experience, like shared domain model, all the stuff that you mentioned, but devil like hides in details because you have separate tasks like track cursor, like render something, remember position, and so on. And that's something that requires like hard hacks even in native JS. And so I hated myself in the end because like it was like JSP page that contains SQL queries, and so it was like mix of those JS hacks and Scala.js. So the question, can you recommend how to bring structure to those intermediary code bases that interact with front-end and browser in like native JavaScript and like connects to your beautiful, neat Scala? And so I had no answer.
Yeah, I do not have an answer for you right now because it's not, well, Scala.js was not very well received by a few of my colleagues when I tried to sell them Scala.js. Yeah, they're waving to me. Because, well, it's a very hard concept to talk about because we are using backend language to write frontend. It's not going to be always beautiful. But I see Sebastian is very hardworking on Scala.js right now, and I've never showed you here on my presentation how it works with Scala 3, and I know that there were major changes.
Okay, so my question may be like a bit out of scope, I think, but is it possible to embed somewhat the CSS files also, let's say the CSS files into the Scala?
Yes, there are libraries which allows you to write CSS and then use it on the front end. Yeah.